Okay, good morning, guys. So what we're going to do today, last week we did two different types of word problems. We did on Monday compound interest and on Wednesday continuous interest. So we've been talking about money for the past week or so. So what we're going to do now is just compare the two of them, just so we know when to use what formula. Okay, so on the left it says compound interest formula. It gives you the formula. A equals P times 1 plus R over N raised to the NT. And on the right is the continuous interest. That is your APERT, as people will say. And then underneath that, I wrote when you are going to use compound interest and when you're going to use continuous interest. Very simple. When the problem does not say continuously, you do not use the continuous interest formula. Use the compound interest. When it does say continuously, you use continuous interest formula, APERT. Okay? So if we read our first example, in 2010, Jay invested $15,000 into a savings account that offers 2.15% compounded semi-annually. Compounded semi-annually is not compounded continuously. So you're going to use the compound interest formula. A equals P, 1 plus R over N, raised to the NT power. If we keep reading, it says algebraically determine how many years it will take for the balance to reach 20 grand. So how many years means that you're solving for T. So as always, we're going to do this on the side. You're solving for T, A, P, R, and N. So if you go through, you can plug everything in. So everything stays the same. P is how much you started off with. He started off with $15,000. We want that $15,000 to turn into $20,000. R is the rate, is 2.15. Again, you move that decimal over twice, 0.0215. And N comes from how many times a year it's being compounded. When it's compounded semi-annually, if you remember, semi-annually means that it's happening twice a year. So N is 2. So we plug all this stuff in. So we have 20,000 equals 15,000 times 1 plus R is 0.0215 divided by 2 raised to the 2 times T. So to solve this, you look for your variable. The variable is up in the exponent, which means you're going to have to eventually use logs. So the first step in using logs is dividing by the 15,000. This cancels out. On the left side, you get 1.3 repeating, or you could write 1.333, the 5 decimals, equals. If you want to clean up what's inside the parentheses, you can. That ends up being 1.01075 raised to the 2t power. So now to bring down the exponent, you take the log of both sides. So you have log of 1.3 repeating equals 2t times the log of 1.01, so 1 over here, 1.01075, and then you divide the log. So divide, you get 26 something when you're done. On the right side, it'll cancel out. So I'm going to bring this up here. So on the right side, you'll get 2t. On the left side, that number that I just mentioned, the 26.90470, 5 decimals, you got to write. 26.90470. And then lastly, divide by 2 to get t by itself. We are rounding to the nearest hundredth, 13.45 years. Okay, so the only new thing that we're doing today, the only thing that's different from what we did last week, is just knowing when you're going to use compound interest and when we're going to use continuous interest. Once you make that decision, everything else is kind of old stuff from last week. Number 2, Bryce invests $200 into a savings account that earns 1.85% Compounded continuously, that's the magic word. So whenever you see continuously, that formula A equals PERT, A PERT. We are going to be determining how much money will be in his account in 8 years. So the future dollar amount, that's your A value. So we're solving for A. So we have to plug something in for P, something in for R, something in for T. So P is how much you started with, which in this case he invested $200. R is the rate with the decimal moved twice. So 1.85 becomes 0.0185. And T, we want how much money will be in the account in 8 years. So T is going to be 8. So you plug all this in. A equals P, E, raised to the R, and then T is 8. Okay? You don't plug anything in for E, right? We did that last week. You do not plug anything in for E. E is not a variable. E is a special decimal, kind of like pi. So to solve this, your variable is isolated already on the left side, so you just have to plug the right side into your calculator, and we're rounding to the nearest cent, which is 2 decimals. So when you plug this in, you get $231.90 when you round it. Okay. Number 3, you invest $4,500 into an account that has a fixed interest rate of 1.25%, compounded continuously. Continuously is a PERT. Question is to algebraically determine how long it will take. That's T. You're solving for T. You have to plug something in for A, plug something in for P, plug something in for R. So you invested $4,500, so that's your starting amount. Has a fixed interest rate of 1.25, so 0.0125. And we want the dollar amount or the balance to turn into $5,000. So you plug all this in. So you have 5,000 equals 4,500 e to the 0.0125 t. The variable is in your exponent, so you're going to use logs. The base is e, so you're going to use a natural log if you want. If you want to stick to how we've been solving and do log of this equals the exponent and then log of that and then divide it over, totally fine. First step though, you have to isolate the base and the exponent, so we're going to divide both sides by 4,500. Your algebra teachers next year might call these steps, they might say divide, log, divide. This would be the first division. So it cancels out on the right. On the left you get 1.1 repeating equals e to the 0.0125 t. Now you take the logs, that's where that, again, divide, this is now log. So you have log 1.1 repeating. I'm sorry, not log, I just told you. The base is an e, so you're going to use the ln. Sorry, ln of 1.1 repeating equals, on the right side, the exponent comes down. Then you have ln of e. ln of e is 1, so it cancels itself out, right? Anything times 1 is itself. So all you have to do to get t by itself is divide by 0.0125. So in the calculator, this is what you're going to type in. You're going to do ln 1.1111, right, that decimal that you had a second ago, close the parenthesis, divided by 0.0125. And it'll cancel out on the right side, and you'll end up with your answer, t equals, and you get, rounded to the nearest tenth, 8.4 years. All right, and then the last one. Charles has $500 that he invests into a savings account with a 3.2% interest rate, compounded quarterly. This does not say compounded continuously, so we are going to use our compound interest formula. The question says, algebraically determine how much money. So again, that's your future dollar amount, your future balance. So that would be your A variable that you're going to solve for. So solve for A, which means you need a P, R, N, and T. So he had $500 that he started with. 3.25, so 0.0325 is R. Compounded quarterly. Quarterly is 4 times a year. And we want to know how much money to the nearest cent would be in the account after 15 years. So we have A equals P times 1 plus R over N raised to the N times T. And now all you have to do to solve this is plug the right side into your calculator. Again, the variable A is by itself on the left, so all you do is plug in the right to solve for A. We are rounding to the nearest cent, which is 2 decimal places for money, which gives us $812.52. Okay? Again, this is due tonight at midnight with your notes being uploaded. Tomorrow you're going to have a homework worksheet that looks kind of like some of these problems. Okay? Let me know if you have any questions. Have a good day.